Science on our side. Flat Earth beats on, it's all pretend. But facts will be died. Get ready for the smackdown. Get ready for the smackdown. They'll lie while the earth spins around. Watch out for smackdown. They cling to ancient misconceptions. We've got truth in our possession. No room for doubt, no time to waste. It's time to put flat Earth in its place. Here comes the
Welcome everybody to Tuesday night on a Thursday. It's actually Friday now, making it Black Friday in the United States. Welcome, I'm glad you're here. We will be looking at a video by Gigantor. I have never covered Gigantor before. Some people call him Pucket Word. His mom calls him Nick when she's not calling him, oh dear God, please stop embarrassing me. But before I show that, I want to the person that brought to my attention this video is a mentally insane person named Simon Mavropoulos, and he is severely mentally insane. Flat Earth does that. It's a gill net for people that have severe mental issues, amongst other things. For example, John Pucket, Marissa with the eyes, Simon in the UK. What's his last name? I don't know. He's been on here before. He's also an anti-5G nut. Raid math. So that's kind of what Flat Earth does. So, is it buffering? I don't know. Looks good here. I'll see if I can. There you go. That might help. Anyway, so Simon Mavropoulos, I need to show you. So, he posted, he trying to puff up his chest. He posted this video to Gigantor. And I watched it. I'm like, wow, this is so incredibly bad. But here is his comment. This is a video that I put out shortly, just like 25 minutes ago. And so you can see here, Simon Mav here. That's the guy. These are his comments. Look at his comments on here. There's 25 comments on here right now. Let's see what we get if I reload. It's reloading right now. I want to make sure. Oh, that's not it. Wow, man, he is nuts. There's 81 comments now. So, all right. He says there's no 24-hour circling sun. Oh, let me do all. He says there's no 24-hour circling sun. For weeks, I know for a fact it's only daylight. I said this comment won't age well. So, anyway. And AJ Finch, I mean, nails it right here. I mean, that there's no better words to describe Simon Mavropoulos than this. Yeah. Anyway, but look at his comments on here. That's one. 2. And this is the link to that video right here. He says he thinks I'm running from it. I'm about to review it. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. The 24 top level comments on this video that I posted 55 minutes ago. So he is absolutely, without a doubt, mentally insane. He lives in Australia, so I don't know what their mental institutions are like there. Probably not all that different from in the United States here. So in the United States, in decades past, Simon Mavropoulos would be safely housed in an institution with people that are called orderlies. They would have at their disposal jackets that would cause him to hug himself. Simon, when he was acting out, could be put into a room that's all soft on all the walls. And then they could, give him the medication that he needs to not be a danger to himself and others. But that's not the world that we live in at the moment. At the moment, people that are mentally insane, like Simon Mavropoulos, are free to post on the internet. Good or not, I think it's probably not good. People that are mentally insane like him should probably have some sort of, borders on them to protect other people from them, not just physically, but also from the type of quite awful abuse that they put on. So that they send to other people. So let me show you. Let's see here. Let's see. Wow. Yep. All right. So I'll show you the DMs from him that I've received. Just so you know, this is a case for having him involuntarily housed in one of these institutions. So let me get so that you see just what you need to see. So, all right. And I get this a lot. From Flatties. This is common from Flatties, but he's on the more evil end of the spectrum for how he treats people. And so seriously, I think it would be best for society if people like Simon Mav were kept away from others online included. So here is from today. Let's see. He says, can you solve the Rubik's Cube? So before, where'd I put my cube? Where'd I put it? Hold on. I had it. Oh, dog, it's not here. I had it in here earlier, but it's not. I brought it out or something. Well, all right. I'll have to find it later if I can. Otherwise, oh no, there it is. Simon, I can solve the Rubik's Cube. It's not that difficult. I don't know why he would say that. So I'll show you. Yeah, he is. Yeah, I mean, Simon, your mom doesn't even like you. She hates you, Simon. Your mom hates you. She's embarrassed by you. So, all right. I don't know why he would. I mean, like it's not too difficult to do if it's just patterns. It's just memorizing patterns. I figured out some of these myself, but for the most part, it was other patterns that I memorized. My cousin taught me this one. This pattern here. Looks like I'll only need to do it 4 times on this cube here. Yeah. Oh, I messed up. Hold on. No. I screwed up. I'll have to do it more than 4 times. Okay, there we go. Top rows. Ooh, got lucky there. Here we go, Simon. I'm almost there. I don't see him in the chat. But I think he'll watch later, won't he, Simon? I have seen the guy that solves 3 cubes while juggling. That's insane. There we go. There you go, Simon. You saw me do it. Yeah, the guy that juggles it, he catches it, and then before he throws it, he rotates it with one finger there like that, and then throws it up again, and then he catches it, and then he catches it again, right? And he rolls it again while catching. It's quite something. So, all right. I'm not going to play an excerpt from the call. He called me on Facebook Messenger. Of course, I recorded it. When insane people call me, I record it. So anyway, yeah, it's on my Conspiracy Tunes channel if you want to go watch. I don't want this video demonetized. That one was not monetized. It can't be monetized. So anyway, you're going to have to read this yourself. I'm not going to read these out loud. Again, because I don't want this to be demonetized here. Anyway, so you never answered, can you solve the Rubik's Cube? Of course I can. So then here is today, 3:32 p.m. He sends that link. This is to the video I'm going to be reviewing a little bit. He claims I'm going to get rolled. He said, it's adorable when flerfs try to do math. They always fail. And of course he did. Anyway, so this is how dumb he is. Like, this is the level of discourse that he has, right? This is it. Just calling names and everything. So he says my math is wrong, but of course he can't do math at all. Simon is incredibly horrible at math. This is a link to the video you're watching right now. I sent him. So I told him to tune in to see real math. It'll go over your head. And then just look at this here. I'm not gonna. He wants to bet $1,000 on whether or not there's a 24-hour sun. Of course, all flerf bets are fake. For flerf challenges are fake. It's the second law of flerf. So I've told him, hey, go put money on the bet moose if you want to bet against me. You could. The way it's balanced right now, flatties have quite a significant amount of money to win if that goes the way that they say it's going to go. So anyway, then he goes to this, right? I don't know why. Why does he have to do these kinds of things here? Then he does get more. See that? Why is he in here? Why is he doing that? Well, because he's just a horrible person. I say more proof that flerfs are evil. He claims to fight demons. Obviously he's got the sides mixed up here, it seems. Anyway, he keeps going. This is a par for the course. He said that I deleted the video. You're watching it right now, people. I sent it again. So anyway, and he just keeps going. He just keeps going. He says you can't even solve the Rubik's Cube. Just did. Look at how measured flat. I keep asking for the measurements. I never get any. So yeah, there it is. There is Simon Math, that absolutely 100% certain mentally insane individual. So okay, this is the video we're gonna watch. And this is Pucket Word. Goes by Nick or Gigantor. And let's listen in a little bit. He's gonna go over some. The name of this is the Flat Earth secret exposed, how level got curved for a globe model.
Hello, Flat Earth researchers, debaters and debunkers. Nick here from Pucket Word, and today I want to demonstrate what I hope is the simplest way to understand how the distances measured on a level Earth are converted into distances on a globe model. So we'll do a bit of whiteboard work, and of course we'll be talking in terms of nautical miles and degrees, because that's how the coordinate system, namely latitude, has been worked out, which is then converted into a globe. But it all started with...
This is important, it all started with
people measuring distances on a level Earth and making observations.
And of course, now he's using the word level incorrectly. The word level, when referring to the Earth, is a curve. He means flat. So, flat.
Into the sky, looking at either a star such as Polaris or the sun, and then calculating the distance the observer is from that ground point. And then by having those distances using nautical miles and degrees, the angles that are seen of the stars or the sun above the horizon, a level surface, are then converted into a curved surface for a globe model.
So he said he's making claims that it was first determined using flatness and then converted to a globe. So we'll see how that goes.
So first of all, let's just have a look at a document I put together that shows the relationship between nautical miles and degrees.
I will save you the several minutes he spends going over this and just point out that he got this mostly correct, though. The globe Earth circumference on near the bottom there, where it says 39,350. That's not, I don't know what he did for the formula there. This is the spreadsheet. So it's 40,000, and you can see row 17 has in kilometers, it says 40,003. So that's the correct one for the circumference of the globe. For some reason he got 39,000. I think it's in the conversions, and when you do convert, right? So this is the error happens in the third digit, though, third figure in the globe Earth circumference. So I don't know. It's 40,000 is the correct number, but when you're doing conversions, and especially if you're doing multiple steps of conversions, if you aren't using enough sig fig in the conversions, then you can accumulate errors, and that's probably what's going on there. Not a big deal. Just want to point that out. It's close enough for just to show what he's doing. I don't know why he spent a lot of time on this. Let me jump ahead then. Wow. Okay, there we go. Here we go.
This translates to a globe model. So first of all, let's look at how celestial navigation and working out distances for latitude are worked out.
So this is a guy who has never done celestial navigation, and he's going to now tell people how to do celestial navigation. This is, of course, an example of extreme Dunning-Kruger. He's never done it. He has no right or position to be telling people how to do it. And clearly he doesn't understand the topic, as you'll see.
So the title is very simple: How Flat Earth Distances Are Converted into Degrees for a Globe Model. So here we have the level surface. It could be the water, it could be the ground. And we have an observer here. Okay, he's on a boat, and he's using a sextant or some kind of device to look at what could be the sun or Polaris, okay? An object in the sky that's used as a reference.
It's always interesting. Flat Earthers only talk about Polaris. When they think all celestial navigation just uses Polaris. You can use any star that has been cataloged and where we know the GP is over time. But they don't quite understand how it works, so they like to use Polaris. Stars like Polaris or the sun. And he did get that right, though I don't think he meant to.
So directly under that sun or star is the ground point. All right, so we're going to work out in celestial navigation terms how far this person is from that ground point. So that's basically how distances were worked out. Doesn't matter
how distances were worked out. So now let's put ourselves back in time to the people that were figuring these things out. Right now, before they knew the shape of, not the shape, sorry, before they knew the distances between lines of latitude and the relationships between the lines of latitude, let's use Polaris as the example, because it is nearly over the North Pole. How far, or what's the angle to Polaris you can measure at some position, right? And I live in Minneapolis, and a lot of this was done in England, where 45 degrees goes through both places. So let's use 45 degrees. Actually, I don't know if 45 degrees goes through England. I think most of England's north of 45. Let me see where 45 cuts through. He uses 40 in his example, so it's pretty close, but certainly not England. Let's see. Oh, you gotta go down to, wow. Yeah, you don't even get there. You gotta go to France to get to 45 degrees. Way south, and he uses 40. Wow. Okay. So yeah, 45 degrees goes across France, not far from Monaco, crosses Italy. So, let's say it doesn't matter that much. Let's say you're at some position and you measure the angle to Polaris, right? And then you move some distance straight south until you get to where it's 1 degree lower in the sky. Right? And you say, oh, well, how far was that? Let's just mark that and let's just call that 1. Right? Let's do it again and see if we get the same distance again, right? Go farther south. What do we get for that distance? Oh, look, we got the same distance. Wow. Okay. Let's do that again. We got the same distance. Now, at this point, you can say, yes, we know that whenever you move enough to dip the angle by 1 degree, you've moved that same distance. Okay. Now, and I know, there's only one shape on which that works. But let's just imagine for a second that people are still scratching their heads and trying to figure it out. So then what? Right? That's all you know. You don't know the shape yet. All you know is these distances and the relationships. But you can start to then figure out some things, and you can say, well, let's draw out how that might work in to see if it let's do what the flatties want to do. Let's presume flat. Let's start there, okay? Let's start there. And I'll use 45 just because I have a 45. I don't have my protractor. I don't know where the protractor is, but let's start with this one here. Right? We'll put a point there. We'll put a point there. And we'll put a point there. Right? So here is there's Polaris. Okay? And then we've got our straight lines. I could have used the triangle while it was there, but I missed my opportunity. All right, so this is similar to what he was just showing. Now on this diagram, we've got 45, meaning that this is also 45. And of course, this is 90. So now let's do what he said people did must have done. Let's move a certain distance this way. And let's see what we get. So when we go to 46 or 47 or 48 or 50 or whatever, is it going to be the same? Well, we're going to run into a problem, aren't we? Those are just numbers. Reification fallacy, glerf math, dopey dope. I don't have my protractor. I'm going to have to, what am I doing here? What should I do? We got 45 and I didn't measure. Is it going to work out even? It should. 3.5 inches. So at another 3.5 inches, here's where we're going to have, there we go. So this is, for Polaris, this is 90 degrees, right? And here is 45 degrees. Now we know this now, but they didn't necessarily know that then. And this is the equator, right? So now, does that relationship hold? We're going to have some trouble. I know. So because when you get to the equator, this angle doesn't follow, because it should be whatever this is here, right? Like I said, I don't have my protractor, but according to Flat Earth, according to what Gigantor claimed, this is what it must be. This is the application of the geometry that he said. I love it when they try to talk about geometry, right? And that only works in echo chambers. Because how did that happen? He likes to claim history. That's what he's doing. He's claiming history, but he doesn't have any reference to it. Maybe somebody could do what is this angle here in applying this, right? Because this is we know this one is hold on, I'll get the I'll run the number there. There we go. So it's 2,700 nautical miles between the North Pole and 45 degrees north, and then another 2,700 nautical miles. So what does that give us for this angle? According to the geometry that he claimed was what they used, right? This is what's important. This is what he said they did. He said they applied geometry. Right? And so we're going to apply geometry and see if it works. So now I forgot to mention, since this is 45, this is 45, this is 2,700. You can measure that going across the ground. That means that this is also 2,700. Now when we get to his diagram, we'll see what he says the height of the sun is, or sorry, not the sun, Polaris. So, B is 400. And this angle, here we go. I'll do it in red. This angle here, now applying the geometry that he just claimed, (26.6 degrees). This is what he just claimed. If you start at 45. So, oh my goodness, you're right. Nautical miles, not degrees. Thanks for the catch, Zoom array. So there's this. This is the application of the math that he's talking about, right? But let's watch him. Let's watch him shoot himself in the foot a little more.
To whether you assume the surface to be curved or level, physically it's level, and it is assumed to be level like this. Now the bone of contention that globe Earth believers will have about level is the assumption that when you draw parallel vertical lines like this, that those parallel lines are not parallel. They eventually converge in the center of an assumed globe. But
Measured
you
globe.
have to have some measurements and calculations to get there first. So we have our guy on a boat using a sextant, and so we've got another vertical line of parallel lines, and of course we have our horizontal reference here. So the surface is horizontal, and the observer's line of sight is also horizontal. Well, you need that for the angles that you're going to measure. Okay, so the way they do it in celestial navigation is we obviously, because of this horizontal here and this vertical.
This is what's hilarious. A person who's never done celestial navigation has the misplaced hubris to think that he could make a video instructing people on how to do celestial navigation.
Here we actually have a 90-degree angle either side of this vertical line. Okay, so okay, you can call this horizontal perpendicular to down, or perpendicular to vertical if you like, but horizontal it is. That's how it's done. So the person on the boat makes an observation to this sun or star, and there's going to be two angles here. There's going to be the angle between the horizontal, and that would be the observer's view of the horizon directly in front of them at eye level, and then up to here, okay, the angle of elevation if you like. But what's actually measured in terms of making these observations is the difference between the vertical and the angle to the star or the sun over here. So the reading this person might get is something like 50, let's say this angle A is 50 degrees, okay? That's the reading that they would get. So we've got our...
Now, here just shows how incredibly stupid he is. A sextant, which he's never touched. He's never used the readings from a sextant. He doesn't understand how any of this works. He just claimed that the angle between vertical, that you measure, the reading. Anyway, let me just show you a sextant which he has never touched, and I am currently holding in my hand. Thank you, Bob the Science Guy. This is a sextant. This is a bubble sextant. So there's a bubble inside. Pretty cool. Pretty cool. You gotta you get the let's see. You get the bubble just right. Where'd it go? There we go. There. So there's the bubble is correct. And then you sight the star in it. I'm not, of course I can't see a star. I'm inside. So anyway, the point is he just claimed the wrong thing about what a sextant reads. He just claimed the top angle there is what it reads. The top angle is what you want when you're doing celestial navigation. But the sextant reads the bottom angle. The B on his diagram is what you measure. And he just claimed, wrongly, that the sextant reads the top angle. Seriously.
50 degree from vertical to that star, okay? So then it's just a simple case of subtracting 50 from the 90 to get this angle here, which is going to be...
It's actually much easier. If any of this were correct, you wouldn't even have to subtract from 90.
40 degrees. So now, with these two angles, we can work out the distance between the ground point and the observer. So let's just
Now, where does he get this number from?
put that in there. Distance. What's that distance going to be? Well, as we saw earlier, we've got 60 nautical miles being equal to 1 degree.
Now, this is the important thing. You do get 60 nautical miles per 1 degree. But when you use the geometry of flat Earth, it tends to be a little funky.
All right. So what we need to do is take this number that we worked out, the 40 degrees, okay? So what we have then is a simple equation of 40 degrees multiplied by 60, because 60 nautical miles is 1 degree. And that is going to give us 2,400 nautical miles. 2,400 nautical miles. And that is our distance. 2,400 nautical miles. Okay. So really what's that established for us? It's not necessarily the direction, but just the distance. If we do a top-down view, let's say that we are looking down at Polaris, and we've got this, now we have this distance of 2,400 nautical miles from this ground point, and but then that could be anywhere on this circle around the ground point. Okay, so we could be here, we could be here, we could be here. Okay, that all comes down to longitude and other things, but for now we're just focusing on the distance. Okay.
All right. So let's take what he's done there, and let's do the step that he's missed. Right now he got, what did he say? 40 times 60. Now cheat code time. This isn't just 60. He didn't do the units right. Right? It's 60 nautical miles per degree. That's the units, right? These cancel. That's why you get an answer in just nautical miles, because the degrees cancel. And flatties don't understand units; they never use it. But that's what you get. Now he wants to do this triangulation. That's what this is. Well, there's something that means that we get to do next. We get to say, well, how high is the star? This mandates that the star be a certain height. And since we have 1, 2, 3 facts about that triangle, we can solve the triangle. Now, a lot of flatties don't even know what it means when you say solve the triangle. Now, I would recommend using an online right triangle calculator. I use calculator.net to do it. It makes it easier. If you want, you can use SOHCAHTOA. But when you do this, how we can solve the triangle, we can get this height here. Now, of course, this angle here, we know has to be 50. We can just figure that out ourselves, because we've got 90, and then that leaves only a certain amount left, right? There's only 90 degrees left, so we got 40 here, we have to have 50 here. What's this here? Well, there's a little bit of trig to do to get that. And this was done in the comments by Baux, who was in my comments earlier, but he was in the comments of Pucket Word's video earlier today. But Pucket Word, of course, was not smart enough to understand it. So that means that according to Pucket Word, the Polaris, or any star, because he says this works for any star. Apparently it also works for the sun. That's how high they are. Right? He just declared this. Now, in the comments, we're going also Nathan Oakley sent people over here. So I'll get to that in a second, but let's convert nautical miles to miles, and we'll just do 2013. Again, you don't have to memorize everything or do it by hand. So now Pucket Word has just declared that it's 2,317 miles high is how high all the stars are. Right? Pucket Word, that's what you just claimed. Right? It's in your video. It's on your screen there. It's right there. You did it. This is your triangle. You did the triangulation. All right. He was so proud of himself, right? Look at that. So proud.
2,400 nautical miles.
That's it. Pucket Word. Pucket Word gave us a triangle, gave us 3 facts from the triangle, and we solved it. Now let's have a look at some of these comments. Ramen Noodles Ortiz actually paid him $20 for this misinformation. And Pucket Word says, thanks for the crew at Flat Earth Debate for a detailed critique of this vid. Watch it here. So apparently, Nathan Oakley agrees that all stars and the sun are 2,317 miles in elevation, because when you do triangulation, as he did, then this is what this gives them. So for flat Earth, the sun, the stars, they're 2,317 miles high. We'll test that in a little bit here. But, and of course, it's all wrong. Completely wrong. And the fact that, this is the interesting thing. The people that are in here saying, wow, love it, they're dumber than Pucket Word. Right? And of course, no surprise, Ramen Ortiz, another person who's mentally handicapped, is in there thinking it's pretty good. We have another one here saying that Nathan Oakley sent me. But here we have Baux. Oh, hold on. I wasn't showing it. This guy saying Nathan Oakley sent me. And we have Baux. Baux100669 says, so what you're saying at 1040 in your video, the celestial object is 2013 nautical miles high, which is what I got. We know this by using basic trigonometry, which tells us the height equals x times tan theta, or height equals 2400 times tangent 40 equals 2013.84. This is a problem. Now we know the height of the celestial object. We can use that to test your flat Earth celestial navigation theory. Again, using trigonometry. If we observe the celestial object at, say, a 20-degree elevation, we can use the known height of 2013 divided by sine 20 to give us 5,532.98 nautical miles. But wait, that would be 3,132.98 nautical miles over the next 20 of elevation drop, or 156 nautical miles per degree. You see, it all breaks down. There must be an error here. So let's go over the other way by increasing the elevation angle to 70. The known height of 2013, and it gives us 732 nautical miles. Hang on. That's 1 point, I think you mistyped that. There's 2 decimals in there. Or is that a comma? 1,667.02 nautical mile variance in the initial reading. It just doesn't work. And then Pucket Word says, nope, you're saying all that. Good job, Pucket Word. Baux says, no, mathematics says that. By all means, if you could disprove mathematically what I've put, I'm all ears. And so that's the thing. right? Does Pucket Word come in and say, hold on, you got your math wrong? No, he says, you're not all ears. You're not here to listen, right? Rather than point out the error, Pucket Word, the very, very expert Pucket Word, my vid is very clear about what maths does or doesn't prove. You just came here to argue. Well, he didn't set him straight. Nick, if he's wrong, set him straight. You know, show you your superior use of trigonometry. One fundamental thing that you have to understand here is that the equations I used work all on their own. You do not need side-on observations. Wait a second. That's a side-on observation, you double-speaking snake. Which are just illustrations, just as circles are an illustration of the level distance converted into blah, 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 blah. The actual height of the star is irrelevant. No, it's not. You drew a triangle. Why would you draw a triangle if the height of the star is irrelevant? How did you know the distance was 60 nautical miles per degree and then draw a triangle? That makes no sense at all. This is how incredibly stupid flat earthers are. So, anyway, good job, Baux. Yeah. This is the desperation of flat earthers. Yeah, here they go. You'll never see them using curved lines. Why would we use curved lines? We don't need to. I can't believe people actually are complimenting him when he's so completely wrong. That makes complete sense, even to me. Well done, Nick. And so this even to me comment tells me that Code Puncher is dumb and knows that he's dumb. Hey, Code Puncher, if it makes sense to you, even to you admitting that you're dumb, maybe it's wrong. You're not capable of determining right from wrong because this topic is, by your own admission, beyond your comprehension. You're not tall enough to ride. Hey, Baux. Here we go. Here we go, Baux. Good work there. And yeah, I'm surprised he didn't block you. Typically, flatties don't like dissent. So, anyway, Nathan Oakley sent me. So anyway, there's that. The rest of it is a bit of a misunderstanding of how celestial navigation. It's kind of there, but not quite for how it works on the globe. But let's see it.
So really, what's that established? We could be here. Okay, that all comes down to longitude and other things. But for now, we're just focusing on the distance. Okay. So over here now, we can see how the distance that we measured here by the angle on the flat Earth is converted into this globe model. Now, when you're talking about latitudes or great circles, it's very important to understand.
Now, he thinks latitudes are great circles. That tells us right there he's not quite familiar. After how many years he's been trying to debunk the globe, he doesn't know what the difference between a latitude and a great circle. It's not. There's one latitude that's a great circle. It's the equator. All others are not. They're small circles. Steve Bauman says, I just went back and forth with Pucket Word in the comment section of this video. I'm pretty sure he's just a troll. Well, Pucket Word's brother is not a flat earther and has been on my channel and some of the other debunkers channels on occasion. And to my knowledge, a little bit of information I have is that Pucket Word Nick is estranged from his family because, as I mentioned before, many flat earthers are mentally challenged in more than just being dumb ways, right? Other ways too. So flat earth flat earth ruins families. Flat Earth ruins relationships. It ruins friendships. Flat Earth is a danger not just to being taught to other people, but the people that fall into Flat Earth then become victims and then propagate the cycle again. So they are that, but it's that there's a certain person that has the right proclivity to fall into Flat Earth. They have to have no understanding of geometry. They generally have had some significant problems where they felt like that they were marginalized in life. And then flat Earth came along for them, and they're like, oh, it wasn't me, it was them, right? Right? They think about these people. Certainly Nick, Pucket Word, in school did horribly. He did not do well in math and science. He sucked, completely sucked. Everything went beyond his head, over his head, and he felt probably, he felt marginalized, he felt bad, but then Flat Earth came along, and he's like, they were all lying to me. It wasn't that Nick was dumb. It was that they were trying to pull their wool over everybody's eyes. But Nick is the one who saw through the ruse. And he's now got the secret knowledge. Right? So it takes a certain person to have that line up for them in a way where they run with it. So, yeah, unapologetically, I'll say that Flat Earth ruins people's relationships, and Pucket Word is one such example. And somebody else mentioned that people that moved to Thailand for a reason. I don't know if that's the case or not with him. I won't do any more than just to state what was stated and put that out there. But the point is, he got celestial navigation on the globe wrong. He said, well, just this is the first of many getting wrongs. I like that one. Where he said that lines of latitude are great circles. They are not. All right, let me read. I got a couple super chats here behind. Icy Spin says, who says dopey glurf? Cringe. It is cringe. It's funny. They couldn't think up their own name for us. They couldn't. They just had to change the F in flerf to a G. Good job, guys. You're so creative. Oh, at least the Discord flerfs are like, they're anti-flat earthers. Boy, that really rolls off the tongue, doesn't it? You mean normal people? Normal people. Like, no, they're not. They're anti-flat earth. They're just against it. Well, yes, I'm against it. Because it's a harm to people. It's a harm to society. It ruins lives. It ruins relationships. There's outliers. Some people find flat earth and somehow manage to maintain a normal-ish life. I mean, there's only so much you can do when you're that incredibly stupid, but, they need taste testers down at the urinal cake factory. So they'll be gainfully employed as long as there's urinals. Algorithm says just play Jimmy Buffett's Changes in Latitudes. I don't know that song. I'm not much of a Jimmy Buffett fan. Thank you for that. Icy Spin says, yeah, but we have personal domes. This is a straw man. So just saying personal dome. All right, so you can hypothesize things like that. You can hypothesize anything you want. That's legit. Totally legit. But then you need to, before you suggest that it's the case, you need to actually go test it. So you need empirical evidence for it. which is where, flat earthers run into the trouble that they never have evidence for anything, for their position. Right? They'll come up with a vague idea, and they'll test it with their community. They'll see, oh, well, is it getting traction? Are people buying it? They are? Okay, let's go with it. Let's say personal dome. What is a personal dome? Don't know. How does it work? Don't know. What's the evidence for it? None. What's the optics what causes the light to bend in the necessary ways? Don't know. Okay, go with it. Yeah, that's how you do it. It's not how you do it. NASA Security Force says a series of straight lines makes a circle. You have a good case there. What do you call an equilateral figure with four sides? A square. And what if you have an equilateral figure with five sides, right? And six sides, seven sides, eight sides. As you increase the order, 8, 9, 10, 11, right? The length of each side gets shorter. And when you get to infinity sides, then you have a infinitely varying angle on a curve on it, and each side is infinitely short, or approaches zero length. So yeah, I guess you can say it that way. Now, some purists might not like. I like to think about 1 over 0 being infinity. Just let me do it. Or can we say 1 over x is x approaches 0 from the positive side? Can we do that? Okay, fine. Do it that way if you need. So I do things sometimes just to mess with people. There's a game called Codenames. You ever played that? Codenames? You lay out on the table, I think, a 5x5 grid of cards. And then as you play it, you wind up placing cards on top of the other cards. Right? And then when you place the card on top, then as somebody, in different teams take turns setting the card on top. So when you do that, you might bump the card next to it, and then it's a little bit crooked, right? So I was playing this with somebody I'd never met before. We were invited over to somebody's house, and then they had some other friends there, and this guy, he's kind of fun, and I'm like getting along and I'm reading him, right? And somebody bumps it a little bit, the neighboring card, and he just reaches out real quick and straightens it. And I saw. And somebody else we're going on, and then somebody, another card is a little crooked. He's like, he fixes it. Right? And I'm like, he's OCD. He's OCD about the cards. So I reach out to, when I play a card, I'm thinking I'm going to do it. And I drag my finger over it intentionally to mess up the neighboring card. And he's like, "Ooh, fix it." And then next time I do it again. And he looks at me, right? He goes, "You're doing that on purpose." Like, of course I am. Of course I am. Oh, and I know some of you are like that. I know. I mean, we all have like something. I'm OCD about code. When I'm in code, when I'm writing code, and there's an open curly bracket that's in the wrong spot, I'm fixing it. Anyway, some people notice that I put 2 spaces after a period. They're like, that's not the right way to do it anymore. I'm like, yep, you're right. It's not the correct way to do it anymore. But that's how I do it. Because that's how I that's how it used to be. The difference between an N space and an M space, you'd put two spaces after it. But on phones and computer, if you put two spaces on there after a word, it'll automatically put a period in there. It's a shortcut for me. Two spaces is a period. It takes less time than period space bar, and less time than space backspace. So I'm doing that too. Anyway. Lisa says, same, it drives me nuts when formatting isn't correct. Now here's the question, Lisa. Are we going to differ on this? Allman or Kerning and Ritchie? All right. That was a rabbit hole. Baux 10_0 Baux 1 says, woohoo, math got me a spanner. Cop that, flatties. Take it, flats. Darkstar 4400 says all latitudes are great circles on cylinder Earth, and that's correct. If the Earth were a cylinder, then all latitudes would be great circles. And here is my cylinder map that I made when I reviewed a video, but that was reposted by Bob Nodell, where some guy claimed that the Gleason map, the azimuthal equidistant map, he's like, Gleason gave us a hint. He said it's equidistant. And so that means it's equidistance between lines of longitude. And none of the flatties were smart enough to just think, well, what would that mean? Well, this is what it would mean. This is the Earth now. This is because equidistant between lines of longitude, that's what this is. These vertical lines are now lines of longitude, and they're equidistant from each other. This is what you get. It doesn't make sense. But anyway, yes, Darkstar, all lines of longitude are great circles, or latitude are great circles now. Yeah, that's been sitting on my desk there for a few years. Baux has gotta go all. Thanks for the mod. There's a beer calling my name, and I need to go introduce myself to her. Enjoy that beer. I hope it's extra hoppy. Albino Bad Guy says, for $5, honestly, that's sad. If I had a friend who was a flerf, I would try to love them and answer questions for them until they came back to Earth. That the problem is, Flat Earth is a cult. They didn't get there through rational thinking. Rarely do they get out by rational thinking. Some have gotten out, but it's not common. It's a cult. They have to somehow disconnect from the cult. And it ruins relationships. Flat Earth ruins relationships. And that's another aspect, another facet of why people don't leave very easily, because they typically, not always, there's outliers, typically struggle socially. Look at Simon. Simon Mavropoulos clearly does not have any, does not do well socially. Right? How many times did he comment on my video? He just, if you haven't watched it, go back to the beginning of this, and I showed the comments that he sent to me in private messages and the comments that he put on my video. This is not the actions of a person that has normal social interactions. This is not something that Flat Earth brought on. This is how Simon is. Simon Mavropoulos, before Flat Earth, did not have good social interactions. He didn't understand how to have normal relationships. So here he is growing up really dumb, like mentally, right on the edge of mentally handicapped, definitely on the other side of it, I'm saying. And has challenges socially, and then gets into Flat Earth, and because of his Flat Earth stuff, all of those challenged relationships that he had now get severed completely. Like they're worse than before. Certainly family members too. Like if you are Simon's family member, contact me. I'd love to get a little insight to confirm these things. I have spoken with family members of people that I've debated in the past and confirmed this. Yes, before Flat Earth, things were not good. After Flat Earth, they were worse. So they then have this lack of community completely, and it gets replaced with a community of Flat Earthers. And Flat Earthers tend to not question other Flat Earthers. They accept that, they let them act in horrible ways. Nobody is on these comment sections saying to Simon, hey, I'm a Flat Earther too, and why are you doing that? You're embarrassing us. Nobody's doing that. When I go to the Flat Earth Discord servers and somebody is posting things in the live chat that is, disgusting, nobody's in there saying, why are you doing that? It makes other Flat Earthers look bad. Nobody's doing that. They don't call each other up. Call each other out. Say, you're being horrible. Stop it. They don't do that. So anyway, so they get this community of people. And so they've replaced their struggling community of friends and family with another tenuous, right? Tenuous, with another one that doesn't question anything they do. And now they don't want to lose that. And they know if they leave Flat Earth, they're gone. Then they have nothing because they've already damaged the other relationships. So then what? They're doubly screwed. Yeah, I don't know. That's what they got. Is my video choppy? Like, is this choppy, moving back and forth? I'm watching. Oh no, it's not. Okay, it is on my my OBS screen. So, but not on the playback. Verillion says, when I heard American literacy is 51% to the level of sixth grader, it made so much sense. Oh, 50. If that's the case, wow. Yeah. Wow. That's tough. I see Spin says you aren't fighting the derp, instead the ideology. That's true. It is the ideology, but how do you fight the ideology? Right? It's a cult. It's a religious position, right? They don't have this. Pucket word is attempting to apply geometry, and then when we apply geometry, he says, no, you're wrong. Wait a second. You applied geometry. You didn't even do the geometry right. I'm showing you the right way to do it, and you're saying I'm wrong? That's a religion. He knows he doesn't understand geometry. When he was in school, he sucked at geometry. He's not coming about this later saying, oh, I'm going to apply the geometry that I understood so well in school. You didn't understand it well in school. He sucked at it. The Dunning-Kruger, Okay. Darkstar 4400 says, I don't believe anyone has ever said, I think I'll become a flat earther. And that's just sad. That's true. Nobody, and you hear them all the time like, well, I didn't try to. I just happened on it and I didn't blah, blah, blah. Yep. And every story is all pretty much the same. They say they heard about it. At first they thought it was ridiculous. Then they thought, I'm going to disprove it. And they're like, I tried to disprove it. How did you try to disprove flat Earth? They don't say how they tried to. But we all know how they tried to. They tried to by watching more Flat Earth videos. That's what they did. They didn't actually try to, because it's simple if you try. Apply super basic geometry. The sun can't set. It's impossible for the sun to set over Flat Earth. Cannot happen. And to not get that very basic thing, you have to really have a bad understanding of geometry. So, and then they're done, right? Once that's the click, right? That's it. And you can't geometry them out. They didn't geometry themselves in. NASA Security Force says, how do you adjust your chess pieces? Just let them hang over the line. Please tell me you're not an animal. I'm a little OCD with those squares. Well, I don't play chess much. But I'll tell you, I'm OCD aware. Like, there are certain things that I will indulge, and certain things that I don't. But I see it, and I love seeing it in people that act on it, right? And I love them poking at them. I just love it. Sometimes, do you know Dora? Dora and Koo? She's awesome. Dora's a little OCD. Sometimes where was I? Dora lives in the Netherlands. Writes software, I think, a computer engineer. Am I right, Dora? Don't know precisely. Dora's not here. She's asleep. But she'll watch this almost all the time. She watches it. Dora, you post it. I'll pin your comment. What did I see? Because she's mentioned the double spacing. And I saw I was touring someplace and I saw a placard. It was an old house. We're touring an old house, and the placard had what we call in typography rivers. That's where you get the spacing between words to line up vertically. And you don't want that in typography. But there isn't a lot of things that actually gets done to prevent it. Because as long as the line is long enough, you won't get it very often. But I had seen this placard where it was almost all the way down, and I took a picture, I posted it somewhere, and tagged Dora. I mentioned Dora because I thought that the river in that might be a little bothersome to her. I don't know. Borg Emporia says I should be asleep too. Dude, I don't work tomorrow. Tomorrow is Black Friday. It's the day I don't work. So but we are gonna go. We're gonna drive up to the Mall of America area maybe tomorrow. We'll see. Icy Spin says cognitive dissonance knows no bounds, and then Icy Spin says when they get cornered, you get insults. Never fails. Yup, that's true. Lisa says that's just mean. Yeah. Yeah, but then MC Toon won't get 2-for-1 coffee makers. I don't. A couple times I've been arm twisted into going shopping, but my wife doesn't go shopping on Black Friday early in the morning or any of that nonsense anymore. Either way. Oh yeah, Dora's not asleep. Dora's probably at work. Lord Odin Allfather says no matter which way they hang the toilet paper, reverse it. I like that. I mean, over is the right way, but if they're an over person, go put it under just to get them. I like that idea. Yeah, Mall of America will be insane tomorrow. I don't know. I don't think we're gonna go there. We're meeting some friends nearby, somewhere in the vicinity. So, all right, let's get back to Nick here. Pucket word Gigantor, as he's about to get the celestial navigation a little more messed up.
This is not a slice of a globe. It is simply a two-dimensional circle that, of course, is 360 degrees. And so from our
Of course, it is a slice of a circle.
nautical miles and our degrees, basically 60 nautical miles equaling 1 degree, we can now put these two lines. We've got these two vertical lines here that we used on the level Earth, to measure the distance, and they are put here going towards the center of this circle. And so you've got, here would be where the observer is, and here is that vertical line of the star or the sun. Okay, so that would be the ground point. Okay, so this GP here is the GP here on the globe model, and here is where the observer would be. Okay, so we
now he did sort of kinda definitely miss something about the globe model there. He didn't show the line that was measured for using the sextant. How does he think that was measured? Where does he think that came from? This shows that I'm not certain on this, but it's a really good chance that he doesn't have a clue about how it's actually done. So I'll draw a little bit here. There we go. There's the Earth, and he said it's not a slice. It is a slice. I don't know why he says it's not a slice. But we'll go. There you go. Approximate. How'd I do? Pretty close. Now, here's how it actually works. You measure right there. These two lines, even though I didn't get them very parallel, are so close to parallel that they can be treated as parallel, unless you need like 15 sig fig. So that drawing triggers your OCD. That makes me happy. So here's the diagram that he didn't do. Let me show you the diagram he did, right? He missed, you see the one he missed? He missed this one here. Now, because this line here and this line here are parallel, or so close to parallel you can't identify how far they are out of parallel, then this angle here and this angle here are the same. Now, when you do celestial navigation, though, using a sextant, you don't measure this angle. You don't. You measure a different angle. You measure this one here. Let me use a. Where'd it go? Where'd my oh, there we go. Measure this angle. And they're like, curved baseline. How's there's a curved baseline? Well, no, we're not talking. There's no triangle here. So let's call it alpha. Because if it's an angle, it's got to be a Greek letter, right? So you measure this here, and you know that this is 90. Now he mentioned this here, taking the complement earlier, where you subtract from 90. The North Pole is too small. This isn't the North Pole. So this is the measure. The one you measure is alpha, and of course you also have the dip of the horizon and refraction to take into account, right? But let's say you already did that. So then you have this alpha here. So then, but you want theta, so then you just subtract from 90, right? And that's what you want. Then you know this distance here is the one that you multiply by 60 nautical miles to determine how far the observer is from the GP. And that 60 nautical miles is a linear relationship because the surface is a curve, a circle. And it doesn't work in the nonlinear relationship. So I see spin. Yes, I see spin. That's correct. Without, hold on. Do I have? Yeah, here we go. There you go. I see spin. Just for you. Just for you. Lisa. Anyway, people, stop. Naughty. Anyway, so he gets this wrong for how celestial navigation actually works on a globe. But he's I don't know, he's like 50% of the way there, I guess.
Know that we got a 40-degree angle. So this angle here, angle B, is what is put over here.
No.
40 degrees.
No.
Okay.
No. That's wrong.
Again, we've got a full circle of 360 degrees. Now, if we're talking in terms of nautical miles, that means the circumference.
So the reason why it's no is because it's not the 40, it's the 50 in that diagram that he made there. That's why I said he's sort of correct, but he's not there.
The circumference of our circle is 21,603 nautical miles, or thereabouts, okay? And that means that we have a radius of 3,440 nautical miles, okay? So we're going to plug in that radius here, 3,440, because that's the only number that you can get. Nobody ever measured this alleged line or radius down to the center of the Earth.
Of course we did.
It's just that you can draw a circle with 360 degrees, and using nautical miles, then this radius must be 3,440 to give us this 40 degrees, so that we end up with a distance of 2,400 nautical miles across this arc length here. Okay, so basically, if you want to work out the arc length, the distance from this point to this point on a sphere or in a spherical coordinate system, then you're going to need the radius multiplied by the angle. Now again, we didn't have the radius.
So here's the thing. He's saying none of it works and it's presupposed, but the thing is, it all works and it's not presupposed, it's measured. And he calls it spherical coordinate system, but he's just using a polar coordinate system really here.
Yes, but this is just a process of doing some mathematics, isn't it? Because we've got our angle of 40 degrees, okay, and we've got our 60 nautical miles equals 1 degree. So of course we're going to get a circumference based on pi times r2 it has to be 3,440 nautical miles. Whether you consider that kilometers or the normal miles, you can convert that easily. But
he's in Thailand. Isn't Thailand metric?
That's where this radius comes from. Simply because we already had a distance and we only had 360 degrees. So that's what gives us a great circle. It's really just a level distance of 21,603 miles, nautical miles, converted into degrees, 360 degrees, using 60 nautical miles for every 1 degree. Okay, so that means that in 40 degrees, with a radius of 3,440, your arc distance here from these 2 points is going to be 2,400 nautical miles. Yeah? Okay, so this basically is an observation made in the sky on a level Earth, and this angle that we calculated here is now put into the center of our imaginary spherical Earth. Well, not even a
Again, that's the wrong number. Should be the 50.
spherical Earth, our imaginary great circle. Okay, so
Oh yeah, the circumference is wrong. 21,600. He wrote 21,603. Is that what you're talking about? Yeah. He got, I think he got that from his spreadsheet where he's doing a little bit of imprecise unit switching. I don't know.
the globe model is basically made up of all these great circles that eventually give you this three-dimensional shape, because each one is separated by a longitude. So that then you get your slices. Okay, but this isn't a slice. This is just a circle.
It is a slice. If you take the globe and you slice it, you get a two-dimensional portion of it. That's what it is.
Of 360 degrees, that represents 21,603 nautical miles in its circumference. So whichever way you want to do the mathematics, knowing that pi times r, or pi times diameter, gives you the circumference, then you're going to arrive at this radius of 3,440 nautical miles to give you 2,400 nautical miles when you have a measurement or a calculation of 40 degrees here. Again, it was based on looking at the sky from a level surface using horizontal and vertical. So yes, horizontal is perpendicular to down, but it's only made down in different directions because we've made it into an arc length. We've converted the distance into the arc length of a circle. That's the beauty of mathematics, isn't it? Because you can make these numbers anything you like.
The beauty of mathematics, he says. Oh, precious.
But of course, if you're going to actually put the numbers in, then they have to work out with each other.
Wow. If you put the numbers in, they have to work out with each other. That did not happen. That I don't know. It's a bit of a problem here.
All right, but you can draw your circle any size. It doesn't have to be to scale. You just draw your lines, draw your degrees, and say that's 40 degrees. That radius is 3,440 in order to give us a distance across here, this arc length of 2,400 nautical miles. And then you can go ahead and convert it into radians if you want, and then you can use Haversine formulas and make flight plans that basically take you a certain distance. Okay, but fundamentally the latitude was based on celestial navigation. If this was Polaris, then that would put us at a distance of 2,400 nautical miles away from Polaris. We're not at the equator yet, but Polaris would have come down in our view. And so as you get further away, the angle changes, doesn't it, across a level surface?
Of course it does. We'll examine that in just a second here, though.
All right. And so whatever angle we end up calculating here ends up being the angle here to give us a radius and an arc length of whatever that distance is on the globe. Thank you very much.
You're welcome. That was all wrong. All right, let me catch up first here, and then I'll go over more precisely the wronginess. Icy Spin says at least he has evidence. Wrong team, but still. Yes, it is globe evidence. Josh Garver for $4.99. His third super chat says your handwritten alpha is superior to most. Well, thank you. It's alpha is super easy to write. I don't know why. It looks like a fish. That's what I think of. Siggy Sigwald says almost 2 years. Thank you, Siggy. Siggy's back, somebody said. Anna says almost 4 years. Wow. Siggy Sigwald says, I thought Flat Earth had perished after running collectively away from a free trip to Antarctica. They are scrambling. They are scared to death. I love watching it. They can't say quickly enough, it doesn't matter, it doesn't matter, while also making videos on videos on videos trying to debunk the fact that people are going to Antarctica and going to definitely see the sun doing circles for 24 hours a day. Amazing to watch them, and the infighting that it's made, spectacular. NASA Security Force says this is all 2D. Our world is 3D. He's calculating in 2D. It's a problem mathematically. None of these people have ever shown 3D. It's infuriating. Yeah, but when you do this, I mean, this is okay. You're taking a portion of the globe and you're slicing it and making it 2D. That's okay. But yeah, they can't. It doesn't matter. They can't think in 1D. Josh Garver with his third super chat says, wow, this person is awful with mathematics. I don't believe he studied math at all. I think you're right, Josh. I think you're right. He did not do math. He did not do well. Okay, now let's get back to this here. So this he drew earlier. He didn't solve the triangle. He pretended this didn't exist, but he drew everything else. But when you do that, and he had then later said the mathematics works out beautifully. Well, this has an implication, right? If you're going to draw this, then that's how high the star is right there. So, and this formula here is what they got. They're like, well, we just measured across the surface of the Earth. Well, when you measure across the surface of the Earth and you determine that there's 60 nautical miles per degree, that doesn't in and of itself tell you, come from the shape of the Earth. But it can only happen if it's consistently the same. It can only happen on one shape. Not just whatever you want it to be. So let's do this. He uses this formula here, 60 nautical miles per degree. So let's do this for a different position. Let's say that you measure the height of the sun to be 20 degrees. Right? We got 20 degrees times 60 nautical miles per degree equals 1,200 nautical miles, right? So now when we make that triangle, we get 1,200. I'm writing this kind of small. I'll write the answer bigger. And of course, remember, you don't need to do it in your head. Use a right triangle calculator to make it easier. So now the height of this, let me make sure I did this right. B is 1,200 there, right? So now we've got the height of this, remember the height of this triangle is 2,013 nautical miles. The height of this triangle, check my work here, 436 nautical miles. So when you solve the triangle for 20 degrees, you get a different height for the star. You see, that's a bit of a problem. Let's try it at, 70 degrees north, right? Times 60 nautical miles per degree. We get 4,200 nautical miles. When we do the triangle here, it's a bit steeper, right? Not even close. Whatever. All right, let's 4,200 you see, we're gonna run into a problem here because now we have the height of that of Polaris now has to be 11,539 nautical miles. So when we do this, he wants to do triangulation. When you apply that to other locations, you get different heights for the star. Like that's not that's not how you're doing it. It is what you're doing. You drew the triangle. How else do you think this geometry works? This is the application of the geometry you claimed. Why did you draw a triangle then? You had to draw a triangle. Because that's the way you think it works, but it's not the way it works, because then you'd get the same height for it every time, but you don't. This relationship here is an arctangent relationship, not a linear relationship like it is on the globe here. So on the globe, it all is so nice. Because when you move to another spot on the globe and measure the same star, right, it goes off. I've learned I don't want to draw the star on the paper because they're like, oh, it's there. Like, no, it's distant. And so now when we do it here, we get a different, everything's different at this spot. Oh, I didn't draw it very well. That sucks. I'll draw it up here. This is my drawing at fault. Oh my gosh. That's terrible. Oh no, it's not. It's not supposed to be. What am I doing? It's supposed to be perpendicular. All right. Sorry. This is what I'm doing. That's why I got it wrong. It was me. That's oh, now it's getting messy. But we've got two angles here. We've got like before. Okay. This'll sort of fix it. Will it? I don't know. I don't want to mess it up anymore. Anyway, we're going to have, it's going to give us a different alpha. We're going to get alpha squared. Alpha sub 2. We're going to get a different alpha here. And when you do the math, it's going to move linearly. So that's what happens here. If I had a better drawing, every degree that you get farther away, it drops the same linear distance across the surface. It works on this. It doesn't work on theirs. So Icy Spin says because he knows they won't math, so it doesn't matter. And that's the thing. That's the thing. Pucket Word can make that video. And I think he doesn't understand the math. I think that he's complete Dunning-Kruger. He's been a flat Earth influencer for several years. And he's built up this false confidence, this misplaced hubris that he has about himself, where he thinks, Tiny Captain, I didn't draw the vertical. That's what I did wrong. And I drew it a little bit too close to the GP of that same star, so that the vertical and the angle are too close to each other. So that's why, because then they're going to be like right next to each other. So taken care of over a year ago. Let's see what was. It's loading. There it is. Oh, it's loading slowly. on GeoGebra. Let's see if it loads up on here. What's going on? Let's go. There it is. There it is. Okay. There. Perfect. That's correct. So this is a circle here, a slice. What do we get when we zoom in? Yeah, so here we have 90. We have is this 89? 69.81 miles. And here's another, is this another 89? Well, let's see here. 88, 87, 86, 69.8122. It's the same. What do you know? And this is what's really damning, of course. And they will never acknowledge it. They can't, right? Because this destroys it. This destroys flat Earth. Right? That's a nice circle. And you always get the same linear distance between each step. It's, you know, why not accept it? Because they have a religion about it. You know, Pucket word, your math was wrong. And you don't win this by saying your math was right without showing that your math was right. Right? You didn't do it right. You drew a triangle, and that triangle claimed a certain implication about how high the star is. If you're like, it's not really that high, then why did you draw a triangle with the star at that triangle? At the top part of that, right? Why? Why is it like, why did you draw a triangle? You're trying to do the triangulation without taking the implications of it, because it doesn't work, right? You're dishonest when you do that. So, yeah. It's a sad life for them. It's a sad life. So, okay. I'm coming up on a week before I leave for Antarctica. So this is, you know, who you are the ones here that at 1:45 a.m. in Minnesota, the 350 of you, and then those who are watching later, this is, you're the ones that matter. There's several different experiments that I'm doing in Antarctica and on the trip, and I kind of would like to have like a person that wants to like represent or like be the front person for each of those different experiments, and then to handle getting, like, receiving the any submissions if they need submissions. So let me show you here. Let me show you what I'm talking about. So here's the experiments. And of course, the 24-hour circling sun is the top one here. The line of sight to Polaris, that's kind of simple. Like, we're not going to see Polaris. But this one here, angular width of the sun, you know what would be really nice? Would be to have a bunch of people all over the world get pictures of the sun at a certain time, and then we'll get the distance between the person and the sun using flat Earth and applying the geometry necessary for flat Earth to give a prediction and then compare to observation. Another is so like this distance between the lines of longitude. I'm hoping Jesse Gordon, this is his thing, I'm hoping he will do it. Dip of the horizon. Sunspots, it's not on here, but sunspots is another one. But any of these that are bolded on here, if you'd like to, like, kind of front that and take and be be the one that takes the data and publishes it. So I've got flerf.info, which is a Wikipedia site or a Wikimedia site. I can have the data be on here, and then anybody can edit it. And of course, if you're the one that owns it, you can own that page. And so anybody that modifies a page, you can revert their changes. So if you're interested in handling one of these, like being the front person for it, let me know. It'll get the data posted sooner if somebody's kind of handling it. So I would love to have people sending in pictures of the sun with sunspots. And that we'll get both the angular size of the sun and the sunspots in the same like submission. The dip of the horizon, and I've asked for this before, and I've gotten bunches of them. But when you fly, you can measure you can determine the shape of the Earth, whether it's a globe or flat, by looking at the dip of the horizon. Flat Earth has very specific predictions about the dip of the horizon. I have a whole table here I made. Because on the globe, it only varies with elevation and refraction, and at that elevation, the refraction is actually kind of consistent. But on flat Earth, it varies with three things. It varies with their elevation, with their latitude, and the direction they're facing. So I put these in here. I said, well, let's start at 40 degrees north latitude. And if you're looking due north, across the North Pole, you have the farthest distance. And so when you create the triangle, once again, a triangle is something flat earthers can't solve. You get the dip of the horizon for flat Earth to 0.0239 degrees. And if you look south, the shortest distance to the South Pole, you get 0.0423 degrees is the flat Earth predicted dip of the horizon by using geometry. And they're like, well, that's not the right way to do it. You didn't take into account perspective. This is actually applying perspective. So, Calder Vasalde says, once I get a solar filter for my telescope, I will take pictures and send them to you. So I definitely appreciate them, but really for this particular experiment, it needs to be while we are on the ground in Antarctica. So I will be taking pictures of the sun regularly with the P1000. And so since flat earthers, a lot of them are like, it's a solar simulator or it's a different sun. Well, that can be tested easily by just having pictures of the sun taken in Antarctica and pictures of the sun taken elsewhere. So if while we're in Antarctica, you take pictures and send them in, the sunspots are a fingerprint for the sun, and we can just post them online and say, look, here it is in wherever Calder Vasalde lives, and here it is in Antarctica. Look at that. They match. They're rotated as predicted by the globe. And they're not mirrored as it would if it was a reflection off the magical dome. So anyway, I didn't see the personal dome wiki. Did I miss it? No, there is none. So there used to be a Flat Earth wiki. It was hosted on a free site that got taken down because we got complaints from flatties. This one I pay for. Flerf.info is paid for by me, so it can't be taken down so easily like that. So we can get that all up and host it, and we can post mostly whatever we want on there. There's a few people on my Discord server that are already in there and maintaining it. I haven't yet adjusted the permissions so that people can upload pictures. It's not on by default. So, and I have never administered a media wiki site before, so I didn't know offhand how to do it. So I've asked Peter Markley to help, as he's done a little bit, and he's pretty good at this kind of stuff. So Super Ghost UK says, genuine question, on a scale of 1 to 10, how excited are you for the final experiment? I am really excited. I am super. There's a lot of things. I'm really nervous. very nervous about a couple things. This was a large amount of money that people contributed. And so I'm nervous about delivering the value for that money. I'm nervous about being outside for 4 days in the cold. Because I live in Minnesota, I know what it's like to go in the cold. We went for a walk this morning. I put on the right gear. I was the right temperature, but it was an hour. And I was fine, and I was moving the whole time, right? But we're going to be outside for hours and hours and hours at a time, and we're not going to be hiking. It's just ice in this area. That's it. And it's 2 a.m, and we're not going to go hiking up the mountain at 2 a.m, right? We're going to just be right there milling around near where the observing station is, and we're going to just watch the sun moving. So it's not like, so I'm like, will I be warm enough? And I know, I know what it's like. Imagine living in Florida or California and coming there and thinking, oh, now what, right? Because I don't know. That's Jaron and Austin. I don't know. I don't want them to be cold and suffer like that. That's not what I'm looking for. So, am I taking an IR thermometer to take the temperature of the sun like Mikey Smith did? Of course I am. I have one. I'm bringing it. I am. Oh yeah. Okay. Let's see. Roland's not here. Roland is the one that suggested I do this. So let me show you a couple things I did. So anyway, that's my concern. Like, we're in tents. That's it. In a tent is where we sleep, and there's a tent for eating. So basically, I'm not inside for 5 days or 4.5 days. There is no inside, because a tent isn't really inside. Like, oh, I'm cold, let me go in and get warm. There's no go in to get warm, right? There's a tent. You can go into your personal tent where it's not that warm. You can maybe go into the dining tent. It might be a little warmer. So what are your thoughts on Whitsitt saying if the sun goes behind the clouds, they can't get 4 days of constant sun observation? It proves the earth is flat. I don't think he said that. I haven't heard him say that, did he? Yeah. Well, anything they do is pure copium, right? A cloud goes in the way. That's not, any sane person's reaction will not be, oh, sunset, doop-de-doop. No. It's like the idea of object permanence somehow doesn't work for flat earthers. Well, let's give it a shot. Okay, here's the sun. Here's the sun. Here's the sun. Oh no, the sunset. Where did it go? It didn't. It's gone. Oh, there's the sun again. Right? You have to actually not understand object permanence for that to happen. If it goes behind the clouds for an hour, it didn't set. Right? If it already completely did something that was impossible on flat Earth, and it went behind clouds for a little bit, no. Pure copium. You look like, it makes you look like a worse idiot to use that. So, okay, let me show you a little bit of what the marker just came. Markers took forever to order. So these are the markers here, these Sharpies. And I needed to get the silver ones because some of the things that I'm labeling don't have, that they wouldn't get labeled otherwise. So I labeled, and I'm a programmer, 0 index. So these are my SD, or my SATA to USB to SATA. And actually, I ordered another one of these. So this one will get demoted to 3. I'll scratch it out because the good ones need to be next to each other. So the 4 terabyte drive goes in here. I have 2 of those. And so one of these will be for I'm going to use for editing video. I'll just put the videos on here, edit right on directly on there. And then these two will be for backups. And I'll swap out the drives in these two to do backups of all the videos, because I don't want to have the one copy of a video be on one of these little microscopic size of a fingernail cards. Look at this. This is, you know, in here is one whole terabyte, an entire terabyte on there. Now look at this. There's a number 1 on there. So I serialized these as well at Roland's suggestion, and this was a good idea. He said, you know, if you have something that doesn't work and you didn't identify it, how do you know which one, when you come back later, isn't working, right? So if I'm there and I'm like, well, one of these enclosures didn't work. Which one? I don't know. They're both identical. Well, now I solved the problem. They've got unique numbers on it. So very smart of him. Okay. All right. Let's see here. Anyway, I think that's about it. Pucket word. Seriously. You flat earthers, be embarrassed. That was a horrible application of geometry, right? You can't claim that there's geometry there. It was just dumb. So, all right. What do we got? I've been doing daily video on my Conspiracy Tunes channel. Be looking for future ones over there. If you haven't subscribed to that channel, go do that there. And next week I'll be back on Tuesday with a debate. Lisa says, for $5, with great storage space comes great responsibility. Yes, for sure. I have a lot. Saying I have a lot is an understatement. Yeah, and I fixed the error I made before. I zero indexed my SSDs. So this is number 1. This will go. I ordered a new case. This will go in the case. This is number 0. It's got the drive in it already. So there you go. Make sure those cards have working temperature below 0 degrees Celsius. I did. I took the camera and a battery, and I put it in my freezer, and I got 18 hours. Worked for 18 hours before the battery ran out. And the battery started at 90%, so I could get a little more out of it. It won't go... Actually, I won't ever go 18 hours on one battery. So we do have a charging station. And so what I've done is I have 2 batteries per device that I will be using. And then I'll swap out as needed. So I'll have one plugged in charging, and then I'll be using one. And then when I'm near the charging station, I'll just swap as I can. I have a VR camera I'll be using. I have a camera I'll be keeping with me all the time, and I will have the laptop. The laptop I'll need at night because it will take hours to copy over the video files to the backups. So and in my tent there's no electricity in the tent, and my laptop runs off USB-C. So I'll just use the laptop. Will be using a battery. So 6, I'm bringing 6 of those gigantic brickos. So let's see. Did Dr. D head? Well, Dr. D head is definitely a D head. What did Dr. D head do or say? Let's see. So that's my line? Well, yeah, that's not a problem. Hold on. Was it this one? Come on. Yeah. I don't know. I don't see anything. Well, I mean, that's dumb, but wow. Oh, there we go. There we go, Dr. D-head. What a D-head. Why do you have to, why do you go there? The answer is no, but you know, why is that the kind of thing that you think is a question that an adult human would ask another adult human that disagrees with, you know, science, right? It really shows that you're a D-head. So, yeah. Oh, Albino Bad Guy says check your Discord. Let's see here. Send me his opinion. Oh. Is that safe? All right. Hold on. Do I need... I mean, I think I trust you. I think I do. All right, hold on. Yeah, I can't believe... I have I'm always baffled when flatties compliment something incredibly stupid by another flatty. They're like, good job. What are you talking about? That was terrible. All right, here we go. Hold on. You heard it.
Below me, as that little saying goes.
There you go. There you go. NASA security forces, do your best to not sweat in your clothes. Cold weather is hard on protein uptake and depletion. Take things accordingly. How does one control sweating? Oh, well, that's a good question, Lisa. For somebody that lives in Hawaii, it might be a little non-obvious, but all of the gear we're wearing is layers. And they all have zippers except the base layer. So the base layer is a wool, a smart wool, like long john top and bottom. And then on top of that is a like fleece. On top of that is a insulating jacket with down in it. On top of that is a coat that's waterproof and windproof. And on top of that is the big thermal coat. And all of those have zippers. So when you get too warm, you pay attention. You're like, oh, I'm starting to get warm. Unzip. I'm still warm. Unzip. And then one thing is you can grab it a little bit and like push a little bit of cold air in to like chill it kind of quickly if you need. So that's one way. But it takes paying attention. Another is drinking lots of fluids. If you drink fluids, because fluids move heat around your body, especially to your extremities, and so as you have more liquid in your body, then you can move it, right? A little bit thinner blood, essentially. But if you get a little dehydrated, then it doesn't move as freely. So that's another trick. You may want to grow your beard out for extra warmth on your face. Well, no, I hate it. It's actually too long right now. I'm going to do a video where I show what I have to protect my face. So I don't need that. So yeah, dehydration is a big problem in the cold. So they give us a lot of water. We have water bottles. And so I'll be careful with that. I went for a walk today and I've been like, I was going to sign out. I was going to wrap it up, but no, not yet. I'm not. It's okay. It's all okay. So I ordered carabiners, but this is the bag I'm bringing. And I needed some carabiners, so I ordered one pack and I got all of these. I don't need that many, but, and then got the water bottle here. So I've been like just going for a walk with the family. I bring the backpack just to be used to it. Siggy Sigwald says, are there any mandatory training required for this trip? No, there's no mandatory training. They did a health questionnaire and then approved you based on those responses. For safety things, they require that we have insurance. I had to send them my insurance. It is emergency evacuation insurance. So I had to send them that. But no, see, it's a tourist thing is what this essentially is. So they're like, here, we've got some bikes that you can ride up the hill, and here we're going to do a hike. It's optional for you. If you want, we're going to go fly on a plane today. I don't know if I'll do any of those things because 2:30 in the morning is the interesting time, local time. And so if I stay up until 2:30 in the morning and then go to bed at 3, 4, when morning rolls around, they're like, hey, who wants to go for a hike? I might not even be awake yet. So if you see Kurt Russell with the flamethrower, get the heck out of there. Guys, he spins. It's a good thing they didn't require passing 6th grade geometry. Okay. I'm going to wrap it this time. All right. I love this. I love this one. Oh, Siggy. People are trying to stop me. Okay. You can stop me. Siggy Sigwald says, imagine trying to find east while standing in the South Pole. Well, yeah, there's no east when you're standing at the South Pole. But as soon as you move off of it, then you've got east. But it's a pretty small circle. So I'm half expecting Witless to pack just t-shirts and shorts. So they've received all the stuff. Will shipped it to them. And when we're in the hotel in Antarctica, they come up to our room and they go over all our gear to verify that we have the right gear. And if you don't have the right gear, they send you down to the outfitter nearby, and there's several different outfitters, to pick up the gear. So hopefully Witsit packs all of his gear. So NASA Security Force for $5 says the most important part is that protein uptake lessens in cold weather. You will need more protein than normal. It's good to know. I will, of course they feed us, and they've been doing it for a couple decades now. So they know what people need. So I'm hoping that they have plenty of protein, and I'm always happy. I'm always happy to get plenty of protein. Like, I'm a carnivore. What you talking about? I'm not a carnivore, but okay. Meat is meat, I guess, especially when you're starving. Okay, people, thank you very much. Okay, I can't order McDonald's, and I don't know the food offhand. But I've been told that it's good, that they have a good kitchen there. Thank you, Siggy. Thank you, everybody else. And yes, we'll be on the ice on the 14th, providing all the weather is good. And so I hope that neither you nor I get a broverload while we're there.
I'm Nathan Thompson, Joe Biden, oh, and the earth is flat. This dude thinks the earth is flat for me. Blah, 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 brain coach, oh, the battery's dead. Oh, bro, like you, hey, bro, where are my AirPods? I was like, bro, no, bro, and I'm like, what, bro, like I like, bro, cool story, bro. So I'm like, wow, I literally never saw the dude not drunk, bro, like literally ever, okay? It's like, dude, I gave it to you, bro, get an F in life, bro. Hey, bro, cry me a river, bro. Oh, wow, are you what a psycho, bro? Haha, later, bro. Hello, what a psycho, bro. He said, have a nice, bro. I said, I'll pray for you, bro. Shut the F up, bro. You He's but bro, what a weirdo. I don't call the cops. They wear pentagrams on their chest.
and they can only have 105 IQ. I'm not a big fan. Hey bro, Austin's such an idiot. I'm like, what? Because I got kicked off about right? What are you kidding me, bro? You know, bouncing golf balls on hammers and juggling, it takes a little SpongeBob doll starts hitting it. What? Bob is like the OG, bro. What a loser, you going too deep, bro, dude. This is the surface, bro, dude. Like, that's not okay, bro. This doesn't add up. It's a bad look for the flat earth. I will press chargers, bro. Don't make me do this, bro. The bromance is over, you much left, bro. You know what I'm saying? You know what I'm saying? Like, bro, oh, I'm Nathan Thompson. Like, bro, like, calm down, bro. Like, alright, I'm getting bumps all over my stomach, bro. Like, they were smashing me, bro. They were feasting. That is his identity, bro. I'm Nathan Thompson. I'm effing Nathan Thompson. I am flat earth. I'm the best flat earth actress ever flattered. There's nothing without me. What a cool story, bro. He was in prison for literally nothing, bro. You know what I'm saying? I'm like at 10 takes, bro. I'm not exaggerating. Like, cool story, bro. When you see the rainbow in entirety and completion, it's physical, literal evidence that the firm is still there. Rest assured, the earth's not about to flood, bro. You're good, but please stop talking crazy in the checks. I will continue to expose you. Like I said, the clip is only half empty, bro. Geo, bro. Like, love me, bro. Like, love me. I gave Geo the first bone he's ever had. Just get out, just leave, bro. No one cares. Memorize alternative things. Mr. Brain Train, Mr. Smart Genius. Guy flew out to LA and put on a duck suit and stacked toilet paper, saying it was gonna go to the moon, bro. Purposely it misspelled the most important word, bro, to shut, bro. It doesn't add up, bro. Something doesn't add up. Something's fishy here, bro. Yeah, whenever I was like, dude, if you don't stop, go crazy, I'm gonna have to fight. He would just take off all his clothes, bro. Like, what a weirdo. Thanks for much love. I need a safe word. Keep taking that higher road, bro. It'll come back to you. I'm honestly feels disgusting and filthy. I feel like I need to take a shower.